trigonometry. This is Mr. Carlson, C-squared mathematics. Let's get right into 6.2 sum and difference formulas. We're still in Unit 2, analytic trigonometry. So I hope you had a great time learning 6.1, verifying trig identities. We're going to get into specific trig identities, specific trig formulas, and then we're going to see how we can apply them analytically and also with some mild applications here or there. So bell work. Then we're going to go through the homework quiz on 6.1 and then 6.2, the actual lesson. So these are the two questions I have for bell work. More than likely, they will be on the homework quiz. Okay, so pause the video if you need to, get them copied down, and then we're going to get started. Okay, so for these two questions, okay, the first thing I want to notice is maybe a trig identity. Now remember, there's a lot of rules and a lot of guidelines for 6.1 verifying trig identities. The first rule was try to switch everything to sine and cosine if you can. And then really the second rule was work with the most complicated side. And then the third major rule was see if you can apply a specific trig identity anywhere you need to. So this first one right here, I see a couple things. I already have sine squared theta, so it's already in sine. That's nice. But then I also see this, okay, 1 plus cotangent squared theta. Now this right here should ring a bell, okay? This right here should tell us, oh my gosh, that's a Pythagorean identity, because this, what that equals is cosecant squared theta, okay? That is a Pythagorean identity, and we need to make sure we have that at least knowledged in our head. Is that a word, knowledged? We need to make sure we have it in our head. I don't want you to memorize it, but just be able to know it and recognize it, that looks familiar. If you can do that, then you'll be solid, you'll be fine. So that's cosecant squared theta. So that means when I substitute that in, what I have now is this. And then again, I'm working with the most complicated side. I want to see if this actually equals 1 here. Okay, so now what I'm looking at is, okay, well, this is sine, that's cosecant. You should be able to recognize that they are reciprocals. So I have to just change one of them. So let's just change this one into cosecant squared theta. And that is totally available to me because it is a reciprocal. Now I can clearly see that this is over 1, those go poofy, and this is 1 equals 1, which is exactly what I want. Okay, and so it is verified. Remember, I'm not switching over anything to the other side. I'm not subtracting 1. I'm not foiling. I mean, I think if you did distribute or foil or whatever, it wouldn't really hurt. You would probably still get it. But the reason why I like it here is because it's already kind of multiplied together. If I distributed this out, it would basically be giving me two separate things, and then I'd have to figure out how to combine them later. So it's a little bit more steps. Okay, but this is probably the easiest way to get to the answer here. For the second one, they both kind of look complicated. I mean, both sides sort of look complicated. I'm not sure exactly which side you would want to go to. I'm probably going to do the left side because it's a squared, and squared is clearly sometimes the harder side to do. Okay, now it doesn't really matter which, and I've never solved this one before, so I'm actually just going to play around with it. Okay, and so I don't know. Now I do know cosecant squared theta, or cosecant squared t in this case, is 1 plus cotangent squared theta. I'm not so sure that would actually help me, so I'm going to hold off on kind of substituting that Pythagorean identity. But I do know that I can maybe break this apart and try to see what would happen. So I know that this is, let's do my reciprocal identity. So this is sine squared t, okay? And this is all over, let's do this, 1 all over cosine t. Let's do that. And so now I can kind of see sort of where this is going. So let's multiply by the reciprocal here. So that means I have 1 all over sine squared t and then times cosine t. Okay, now I'm starting to see it. Do you guys see it? So this right here, if I combine them, I can have cosine t all over 1 sine t times 1 all over sine t. So notice what I'm doing here. I'm breaking up that squared term into two separate things, and then I'm putting the cosine t into one of those fractions. So now, as you can kind of see this, I hope you can see this, this right here is cosecant, and then this right here is cotangent, okay? So to finish it out, to make sure it's all nice and fresh, this actually does equal cosecant t and then times cotangent. Now I know I'm actually I'm switching them. So if that confuses you, I'm sorry, but cosecant's right here, and then this one's right here. It doesn't matter because it's just commutative. Okay, it's multiplication, so I can switch them if I want to. It does not matter. All that matters is, do I get cosecant and cotangent out of this? I do. Okay, and so therefore it's verified. All right, that one is pretty nice, pretty nifty. Okay, so again, even me, I don't just look at a problem and I'm like, okay, I absolutely know what to do. Sometimes I can because I've just been practicing a lot, but other times I just kind of try something and I just know how to go. If you, let's just say you did this, if you did honestly substitute the 1 plus cotangent into the numerator here, and then you got secant, even with this, you could probably wiggle your way out of it, and I would separate this into two separate fractions, so cotangent squared t all over secant t. And then this, of course, is sort of weird. That right there is cosine, okay? That's cosine, which doesn't really help us. And then this you can change into cosine and sine. You can change that into 1 over cosine. It takes a little bit more steps, but I can kind of see it. I can see how that could probably get here. You may need to combine fractions again, like I said, but you could still get there. You just need to keep going down, keep going down, keep going down. Okay? Which is great. You know why? Because that means it still works. Okay, so either way you work the equation, you don't need to work it in probably the easiest way, the fastest way. You can more than likely still get there even if you take the longer way. And that's beautiful. Okay, that's beautiful. I'm just trying to show you as much as possible the shortest way, and I believe this is probably the shortest way here. Okay, if you find a shorter way, let me know. Those are the two questions I want to go through for the homework quiz for the bell work. So make sure you get those copied down, and let's erase. You will have 30 minutes on all the homework quizzes this week. I am going to give you 30 minutes just because they are sort of complicated. You have to wrap your head around them a lot. I get that. Okay. So because of that, I want to give you enough time to work through them. Okay. So 30 minutes, 5 questions. Some of them you do have to actually type in the verifying identity. Some of them are multiple choice, and some of them you have to actually like plug in as you go, because I think Math Excel sometimes does want you to solve it in a particular way. Okay, it really does want you to solve it in a particular way, which is kind of frustrating. But if you have any questions, let me know. Send any partial credit requests to me if necessary, if possible. And then begin 6.2, sum and difference formulas. Okay, so I'm going to be real with you. This one is probably going to be long. This lesson is more than likely going to be long. It's probably going to be an hour and 30. Only because not the formulas. I don't think the formulas are difficult, but the simplification of it, like how I simplify it and how it just takes a long, long time, that itself is very difficult, okay? That itself is extremely difficult. So I just want to precaution you on that. Okay, so how do I use the sum and difference formulas to evaluate trig functions of angles and not on the unit circle? So basically, sum and difference formulas are nice because now what we can do is evaluate something like sine of 105. Think about that. We can evaluate something like sine of 105, or we can evaluate something like sine of 65 or maybe 200. Okay, so really odd angles that aren't on the unit circle, we can still find the exact value of them just by breaking it apart, breaking that maybe that 200 degree apart into something that I can use on the unit circle. Okay, so that's what's really interesting about this lesson, is that, yes, we're going to be using the unit circle, so make sure you have it out. I already have it right here for me. I'm going to use my Desmos unit circle here. But make sure you have whatever unit circle you have out, and we're going to get started on using these formulas. I will have a formula sheet for you as well. Okay, so this is the first set of formulas that you will need to really not commit to memory, but at least have on you at any given time during this unit. There are 4 of them. They're what we call the sum and difference formulas. Okay, this is alpha and then beta. They're Greek letters, alpha, beta, just like A and B. Okay, so alpha sort of kind of looks like a fish, and beta is just a bee with the tail on it. Okay, so what do we have? We have 4 of them. Cosine of alpha plus beta equals cosine alpha times cosine beta minus sine alpha times sine beta. Cosine alpha minus beta equals cosine alpha times cosine beta plus sine alpha times sine beta, and so on and so forth. And then sine is literally the exact same thing, but notice how it's sort of flipped. So in cosines, you have cosine, cosine, sine, sine, but just negative or positive. That's probably the easiest. But sine is sort of odd because it's plus. You still have a plus here, but then you have sine, cosine, cosine, sine. And notice how they're switching. So sine alpha and then cosine beta, sine beta. So the sine formulas are probably the hardest to kind of commit to memory and to try to, even if you're practicing a lot of them, it's really hard to kind of commit to memory. Even me, sometimes I have to, before I teach a lesson, I have to sort of look at it like, okay, this is what it is. The cosines are really easy though, but the sines are very difficult because they just kind of flip. Cosines are simple, plus and then minus, but they are cosine, cosine, sine, sine. The sines are simple, and that's plus, but then it's sine, cosine, cosine, sine. So all of this stuff is really difficult. I get that, which is why I'm going to give you a formula sheet. So if you go to Google Classroom, this is Google Classroom, yay. You go to classwork page, you scroll all the way down, you see this, you scroll all the way down to what we call analytic trig, that's unit 2. You click on the trig formulas master, and then there's 2 of them here, okay? There's 2 of them. The master one is probably the longest, okay? This one is, a lot of students like this one because it pretty much gives you everything. I mean, everything from unit 1, it will give you everything from unit 3, it will give you everything from unit 2. Like, it's literally goes down to the detail, even like SOHCAHTOA detail, okay? It goes down to the trig functions of any angle detail. It gives you special angles right here. Of course, that's on the unit circle, but it also gives you the unit circle right here. And so it is pretty packed. I mean, seriously, it is intense what it gives you. It gives you the graphs here, how to graph the graphs. And then, of course, it gives you some basic identities of what we learned in 6.1. So Pythagorean identities, quotient identities, reciprocal identities. It gives you the guidelines for verifying the trig identities, the actual guidelines here. And then it also gives you the trig formulas, 6.2, and so on. We're not going to do 6.4, and 6.4 is the power reducing formulas. So you don't need to know that. So you can actually scribble these out right here because we don't need to know those. So if you do want to print this out and have it with you on a test, I would strongly encourage you to do that. Strongly encourage you to do that. Go to your local library, print it off, okay? Tell your mom you need it, or at least save it as a PDF on your phone so you can kind of flip through it and have it for you, because these are formulas you need to know. We will go through the double angle and the half angle formulas tomorrow. That's 6.3. 6.2 is just this right here. So if you want to kind of highlight this, this is 6.2. We will go through the sine and cosine. That's the 4 right here. 1, 2, 3, 4. And then soon we will go through the tangent ones. Okay? So that's what we're going to be doing today. That's 6.2. And then this right here is 6.3. This is also 6.3. Okay? And again, we're not going to do this one at all. Now, you will see on this a little bit more for like product of sum. We don't need to know this at all. Okay, those we're not going to use at all. Okay, so don't need to do anything with those. And then we're going to get into the later portion of this unit. We're going to get into what we call the law of sines, area formulas, and then this starts unit 7, chapter 7, also unit 3. So polar coordinates and so forth, polar graphs and blah, blah, blah. So that's sort of like what we're going to be doing for the rest of the quarter. All you need to do is focus on page 6. Okay, page 6 right now is the most important for you. That's the master. Now, if you want to just do the cheat sheet, the very simple sheet, this is only 4 pages. It does give you some things like the unit circle definitions, domain, range, period. But then on the second sheet, it does give you reciprocal identities, Pythagorean identities, and then here you go. It's actually the sum and difference formulas. Okay, so this one's probably a little bit easier for you to understand because it's so simple and so to the point. But notice it's plus or minus, and so you get plus or minus. So if you do plus, you're going to do plus. If you do minus, you're going to do minus. But here, notice cosine is plus, and then it's minus here first. So notice how this one's kind of put together, the 4 are put together. And so some students don't like that, but some students like the vividness of it, the clarity of it. Like it's just really precise and succinct. That's okay. I don't care which sheet you use, okay? They're there for you. Okay, so if you want to do this, if that confuses you, just know it's plus first and then minus and then plus, and then that's plus, plus, minus, minus. Okay, again, we don't need to use any of that. We will get through the double angle formulas in a little bit, and we will get through the half angle formulas as well. Okay, and then the rest, you also have a unit circle. They even give you an example of how to use a unit circle. And then, of course, we're going to be using the law of sines, law of cosines in a little bit. Okay, so this one's a little bit more succinct for you. If you want to use that, that's fine. Or if you want to use the bigger one, that's fine as well. Either way, you need to have something out when you're using it. Okay, you can use this on any quiz, test, formula, whatever. Okay, all right, these are my 4. Let's get started. So example 1, I want to use an identity. I want to use an identity to find the exact value. So I want to find a side length. That's what the value is. I want to find an exact value of this. Okay? So I won't do this all the time, but I will do this most of the time where I'll actually do, alpha plus beta and everything. So I'll give you the whole formula. Okay? This whole formula is cosine of alpha, that's my alpha, times cosine of beta, and then plus, because it's opposite with cosine here, plus cosine, sine of alpha, and then times sine of beta. Again, I won't do this all the time because it does take up a lot of space and a lot of time. Okay, where alpha right here is my 60 degrees, and then my beta is 45 degrees. Okay, notice how there's a built-in negative. Now, what are we really trying to find here? Really, what we're trying to find is cosine of 15. Notice that. We're really trying to find, guys, what is cosine of 15 degrees? Now, that's obviously not on the unit circle, right? And so when we are asked to find the exact value, like in radicals, in fraction form, instead of decimals, because obviously we could do this in decimal form. If we want to find the exact value, that's tough. Now, I'm not sure if your actual TI-36X Pro can do that. So let me just do it real quick. I'm in degrees. Let's just do cosine of 15. Yes, it does. So it will show you the exact value here. And this is another reason why you should get your lovely TI-36X Pro at a local Walmart near you. Okay? You should definitely get it here because this actually does help. Okay? It does help a lot. I mean, look at that. It solves it for you. So you already know what my answer is. It's radical 2 plus radical 6 all over 4, okay, which is awesome. I'm going to show you how to do it by hand, and I'm not going to show you how to do it on the TI-36X Pro. Desmos obviously will not be able to do this, okay? But please, if you haven't gotten a TI-36X Pro, it helps you out a lot, okay? It helps you out a lot. I mean, look at that. That's fantastic. So I'm not going to spend any more time on the calculator. I'm going to do everything else by hand, but I'm just going to let you know that oftentimes the calculator, the TI-36X Pro, more than likely can solve something like that. Okay, more than likely can solve it. So without further ado, let's get started. What is this actually saying? Okay, I'm actually going to erase this, and I'm actually going to do equals. And then now this is cosine of my alpha, which is 60 degrees, times cosine of 45 degrees, plus sine of 60 degrees, and then times sine of 45 degrees. Now, because I have these memorized, I already know what it is, and this is pretty easy for me to solve. So sine of 60 degrees is just 1/2. And then cosine of 45 is radical 2 all over 2. Where am I getting these? Great question. The unit circle. Getting them right here. So sine, remember, sine is y on the unit circle right here. And then cosine is x. So cosine of 45 degrees is radical 2 all over 2. Sine of, or cosine of 30 degrees, right, or 60 degrees right here is 1/2. So I'm looking at that one, and I looked at that one. So 1/2 times radical 2 all over 2. That's what I'm doing. Okay, that's all I'm doing. All right? Sweet. So just FYI, I don't want to get you guys confused at the very beginning. Plus, sine of 60 degrees is going to be radical 3 all over 2. And then times, that's radical 2 all over 2. Okay? So I just evaluated them. That's it. I followed my formula. Now I can actually start to simplify. So this is just radical 2 all over 4 plus this right here is radical 6 all over 4. Remember, I'm multiplying, so 2 times 2 is 4. And then, of course, this is radical 2 plus radical 6 all over 4, which is exactly what the calculator got. Okay? Pretty simple, right? And you're like, wow, this is it? This is the whole lesson? You're so cute. Obviously not. It's not the whole lesson, okay? This is just a very simple example. This is probably the first 5 questions on your homework, all right? I'm going to erase this, and then I'm going to get to another example using sine, okay? So using sine, what is this? Using sine. So my formula, I'm going to write it out. Again, I'm not going to do this all the time, but now I'm going to just write it out. This is going to be sine of alpha times cosine of beta, okay, plus, I'm just using my formula. Go to your trig sheet right here. Go find, and I'm just using the formula, okay? I'm trusting that you guys have that out somewhere so you can kind of reference that, okay? So cosine beta plus, this is going to be sine of beta, and then times cosine of alpha, okay? So far, so good? So you just flip them. That's it. So I may have done it a little bit differently. I may have put sine first before cosine. It doesn't matter because it's commutative. As long as you make sure one of them gets sine of alpha, the other one gets sine beta, and so forth. And then plus plus. That's all you need to do. So let's actually solve this. What am I actually solving for? What I'm actually solving for, like this one was cosine of 15, because 60 minus 45 is 15. 45 plus 60 is actually 105. Okay, so I'm actually solving for sine of 105. Obviously not on the unit circle, right? Of course, your TI-36X Pro will more than likely be able to do this. I'm going to do it by hand. So what is my alpha and what is my beta? Well, my alpha is 45 degrees. My beta is 60 degrees. Okay, so what is sine of alpha? That's radical 2 all over 2, just using my unit circle. Cosine of beta, cosine of 60 degrees is going to be 1/2. Plus sine of beta, sine of 60 degrees is radical 3 all over 2. That's a 3. Times cosine of alpha, which is 45 degrees, radical 2 all over 2. I start simplifying it out. That's radical 2 all over 4 plus, and this is radical 6 all over 4. So it basically is the exact same thing that I had before, all over 4. Okay, so what is sine of 105? We found that out to be radical 2 plus radical 6 all over 4. Clearly something that could be a decimal. Clearly something that Math Excel will want an exact value for. But if I actually did sine of 105, I mean, obviously I get this. I'm in degrees, I think. Always double check. Okay, I am. Now, obviously, when I did, so fractions and then square root of 2, and then I do plus square root of 6, and then all over 4, I do get the exact same thing here. So Desmos does at least help you a little bit because of the fractional work, or sorry, the decimal, just so you can double check. But again, the TI-36X Pro will actually be amazingly useful because you can pretty much just plug it in. Obviously, they're going to be like, yo, try to use an identity and not a calculator, but I'm okay with using a calculator. So now you can also get radian mode, radians instead of degrees. So let's actually solve this. So sine of 7 pi over 12, find the exact value of that. Now using the fact of this. Now this is so nice because they actually gave us this. Now I'm going to be very clear here. Math Excel will more than likely not break this up for you, which really sucks, which means you have to actually break it up yourself. Okay, which means you have to try to find this stuff out for yourself. This is nice because that means I can say alpha equals pi all over 3, whereas beta will equal pi all over 4. Okay, it doesn't matter which one you make it, but I'm just going to say alpha pi over 3, beta pi over 4. So now what's my formula here? What am I actually going to use here? I'm probably going to use the sign because it says sign, right? And so since it's plus, what I'm going to use is alpha plus beta. I'm going to use this one. Now I'm just going to redo the whole formula. So sine of alpha times cosine of beta. And then minus, this is going to be sine of beta. And then times cosine of alpha. Okay, again, I have these pretty much memorized, at least partially. And so I may kind of do them a tad bit differently. I think your formula sheet says cosine of alpha first before sine of beta. That's fine. It does not matter. It's commutative property. So let's actually get into this. What do I want to find? I want to find sine of pi all over 3 plus pi all over 4. Because when I add them together, I do get sine of 7 pi all over 12. So what's my alpha? Sine of pi over 3 times cosine beta pi all over 4. And then what's sine? Sine is sine of beta, so sine of pi over 4. So just switch them. Cosine of pi all over 3. So that's what it looks like with the formula all written out and all that fun jazz. Now we can actually start solving this beast. So I'm going to solve it. What's sine of pi over 3? That's 60 degrees. And so that's radical 3 all over 2. And then this is radical 2 all over 2 for sine of pi over 4. And then sine of pi over 4 is also radical 2 all over 2. And then this is going to be 1/2. Cosine of pi over 3, that's also cosine of 60 degrees. Okay? What does this simplify out to? So this is going to be radical 6, and then minus radical 2, and then of course it's all going to be over 4. So this is my final answer. So that is what sine of 7 pi all over 12 is. Now I know that's 60 degrees and that's 45 degrees. Okay? That's 60 degrees and that's 45. So that is, yeah, that's nice. Which, oops, so that's why I said I have partially memorized because I forgot a plus. I was like, that's 100. That's 105. Yeah. So this is sine of 105 because 60 plus 40, 45 is 105. So it's really just the exact same thing that we did before. So again, that's why another reason why a calculator would be useful because I messed up there. So make sure you get the plus. Again, that's why they're so tricky. Sorry. That's why they're so tricky because the signs are the plus plus, but they're flipped. The cosines are the minus plus, minus plus, plus minus. So sorry about that, but that's okay. I fixed it. So it's plus, and that's why it's also plus right here. Let's continue, okay? So let me erase this so I at least see it. Okay, sine of 75. Now notice how they don't actually tell you what to use. So you could use it whatever you want. So think about how can I get 75 with special angles I already know? How can I get 75 degrees with special angles I already know? It should be very simple, I think. Well, you have 45 degrees on the unit circle, and you also have 30 degrees on the unit circle. Okay, you can't do like sine of 60 degrees and 15 because you don't have 15 on the unit circle. Okay, you could use exactly the exact value that you got on the last slide because of sine of 15 degrees. or cosine of 15 degrees. You could, but it wants sine, and I think we got cosine on that one. Either way, try to find the ones on the unit circle. Find the ones on the unit circle. Find values on the unit circle that are very easy, like this, 45 degrees and 30 degrees, and that, when you add them together, gives you 75 degrees. So that's what I'm going to use. I'm going to use, so this actually equals sine of 30 degrees plus 45 degrees equals sine of 30 degrees, because that's my alpha, times cosine of 45 degrees, and then plus, I don't want to make the same mistake there, so plus, sorry about that, plus, you're going to have sine of the other angle, so 45 degrees, and then times cosine of the other angle, 30 degrees. So this right here, because my alpha is 30, my beta is 45, I have all this together. This right here is the formula that I will be using. So let's start solving it. What is sine of 75 degrees? So sine of 30 degrees right here is going to be 1/2. Cosine of 45 is radical 2 all over 2. I like to do my little dots in between. I don't know about you, but I like to do the multiplications in between. This is also radical 2 all over 2. And then times, that's going to be radical 3 all over 2. Okay, when I simplify all this out, radical 2, and then plus radical 6, and then all over 4. So you start to see, like, and maybe you're asking me, like, Mr. Carlson, like, it's the exact same thing over and over and over again. Is this really true? Not always. I'm using easy ones to kind of explain how the formulas work, okay? That's what I'm doing. I'm using easy examples to explain how the formulas work. They don't always, and they're not always like that, okay? Just letting you know, all right? So with that said, let's get to the other examples where they're not always like that, okay? So I hope that made sense. That's how you use the formulas, okay? That's just using the formulas. Let's erase this. Okay, so now in the following problem, you'll see something like this on Math Excel, basically verbatim. The expression is the right side of the formula, so cosine minus beta. So cosine of alpha minus beta is this, which means what I want to do, and it's going to ask you to use the formula to find the exact value. But basically, what you're going to do is work backwards. So it's going to ask you what your value for alpha is sometimes. It's going to ask you what your value for beta is sometimes. It's also going to ask you what the actual expression is. Like, what is it actually asking? Okay, so you're working backwards. Okay? If you're like, what? That doesn't make any sense. So I'll show you. Okay? So watch. Cosine of alpha. If this is cosine of alpha minus beta, that means my alpha is my first one. So that is 85 degrees. Okay? This is alpha, which means my beta is 25 degrees. So this is 25 degrees. Okay? So what's the expression? What is it actually asking? So what it's actually asking is this, cosine of 85 degrees minus, because that's my formula that I'm using right here, look up top, minus my beta, which is 25 degrees. And this equals, well, 85 minus 25 is just cosine of 60 degrees. So that's really the expression that I'm trying to find. This is the expression that I'm trying to find right here, which of course is on the unit circle. So then when it asks you to find the exact value of that, we should already know that. That's of course 1/2. So now notice how we're working backwards. Obviously, we didn't need to use the sum and difference formula to find something like that, because how are you supposed to find, the exact value for 85 and 25? It's hard, okay, and I'm not going to make you do that because that's ridiculous. But what it does have you do is work backwards and say, okay, that's alpha, that's beta. Now put them together, given this is the right side of the formula, alpha minus beta. Okay, that's cosine of 60 degrees and then 1/2. So really, if I did know the exact value of 85, if I did know the exact value of cosine of 25, maybe by plugging it on the calculator, I can multiply those two together, simplify all that mess, all those radicals, and eventually I will get 1/2. Okay, so you can get a complicated answer on the end, or you can get a simple answer like this on the end. Does that make sense? So this slide is really just working backwards. Let's do another example of this, but using radian mode. Okay, so you're also given cosine of alpha minus beta, okay, particular values for alpha and beta, all right? So you should be very clear now that this is alpha and that's beta, but what it's gonna still ask you is alpha, what's beta? It's gonna ask you to find an expression and of course the exact value. Okay, so let's go to town on this. So I'm gonna be using this one, alpha minus beta. So your alpha right here is 11 pi all over 12. Your beta here is 2 pi all over 3. Okay, so this is alpha and this is beta. Okay, sweet. Now, what's the expression of it? The expression is this, cosine, again, taken directly from here. So cosine of my alpha, so 11 pi all over 12, minus my beta, which is 2 pi all over 3. And so we need to actually simplify this because I want to know exactly what this is saying. Like, what is this? Okay, I know 2 pi over 3 is 120. 11 pi over 12, though, what the junk is that? Don't know. So let's try to figure it out. We need to find common denominators. Times 4 gives me 12. 3 times 4 gives me 12. So times 4, 2 times 4 is 8. So now what I'm being asked to find is 11 pi minus 8. So this is cosine 11 pi minus 8 pi. That's going to be 3 pi all over 12, which is the same thing as cosine of pi all over 4. So this is the expression that I want to find, which is nice, right? Because that's on the unit circle, and if you don't have that one memorized, you probably should, because cosine pi over 4, just like sine of pi over 4, is the same thing. It's radical 2 all over 2. That's my exact value. Okay, so I hope now working backwards sort of makes a little bit more sense. I don't care to know what the exact value of these things are. Okay, all I care to know is what they simplify out to be when I subtract them or add them or whatever. And in this case, it should be something on the unit circle, which is pi over 4, and then boom. So far what we've learned is how to use the basic formulas. That's the first 2 slides that I went through. How to use the basic formulas. Okay, and then after that, we learned how to work backwards, and this was the last 2 examples, example 2 and example 4. Okay, how to work backwards given a whole formula. Okay, so now let's erase this. Now, sum and difference formulas for tangent. Okay, that was cosine and sine. Sum and difference formulas for tangent is this. Okay, and I love these formulas. Now I will have to share with you, I don't ever really use these formulas, the tangent formulas, like verbatim. I don't actually have these memorized at all because I don't use them. Why? Because when you actually prove these down at the bottom, when you actually prove that this is what it is, how I do that is through a variety of means, okay? Basically what I do is I know tangent is cosine all over sine, okay? Or sorry, tangent is sine all over cosine. Tangent is sine all over cosine. So if I wanted to find, let's just erase this for a while. If I wanted to find that, all I have to do is just say this is sine of alpha plus beta all over cosine of alpha plus beta. Literally, that's all I have to do. Sine of alpha plus beta all over cosine of alpha plus beta. That's it. And then now I can actually expand these out if I wanted to. If I wanted, so sine of alpha plus beta. This is going to be sine of alpha times cosine of beta. And then plus, this is sine of beta, and then times cosine of alpha. And that's my numerator. The denominator here is going to be cosine of alpha times sine, times cosine of beta. So cosine of beta. And then minus here, okay, minus. And then this is going to be sine of alpha and then times sine of beta. And then I can continue this if I wanted. I'm not going to for the sake of time. Oh, but I wish. If we were in class, I honestly would show you this proof. It's amazing. Okay? It's really awesome. But notice, just look. I could simplify this out and factor and like do certain stuff, combine terms and all that fun jazz. And now look. You notice, though, something very particular here, that there's a plus on the top and there's a plus on the bottom and a minus on the bottom, or plus on the top, minus on the bottom, minus on the bottom. This will actually equal, if I simplified it, to be this. How do you think we got these values? How do you think we figured out that tangent equals this monstrosity? We figured it out by using a normal, basic quotient identity. That tangent is, by definition, always and forever will be sine all over cosine. That's awesome. I would highly encourage you, if you really want the challenge, if you really want some rigor, and if you really think this is awesome math, I would highly encourage you to try to finish this off, because it is mind-blowing. Try to finish this off. Look, use your identities, your verifying identities knowledge, and try to finish and see what could you do. What could you possibly do to this equation to get this? Because you can absolutely get from here to there. Okay? But like I said, for the sake of time, I'm not going to show you. And maybe some of you are like, oh, thank God. Or like, nope, I'm not going to do that. And you're like, yes, yep, you're right, Carlson, I'm not. Great. Okay, fantastic. That's okay. But I'm telling you this, I'm not really going to be using these. Okay, I'm really not going to be using those at all. What I'm going to be doing instead is this. So I'm going to say if tangent of alpha plus beta is this, sine all over cosine, I'm going to be using this. Okay, I'm not really going to be using those formulas at all, and I'm going to show you why that is. All right, and same thing, tangent of alpha minus beta, I'm not going to be using all of this. I'm actually going to be using that this, so sine of alpha minus beta all over cosine of alpha minus beta. I'm going to be using that instead. Okay? Just because it's easier, and I'm going to show you why it's easier. Okay? More than likely, always it'll be easier. Okay? I really wish I could have showed you the proof. I'll probably, honestly, after this video, I'll probably do the proof again myself, because I just think it's so amazing. Okay? So, verify the following identity. So we can actually use sum and difference formulas to verify the following identity here if we wanted to. That's, again, if I had the proof, I would go to town on it and I would show you why this is true. I'm not going to. That's why I put a star here. I don't want to take up any more of this video's time, but by all means, you can verify that this is true by just using this side, by using sine of alpha plus beta, and then all over cosine of alpha plus beta. And then obviously, what is cosine alpha plus beta? You already know the formulas. You go down, and then same thing with cosine. You already know the formulas from this lesson. You keep going, and then you would eventually get that. You would verify the identity. Okay? Awesome. Okay, I'm not going to show that to you, though, unfortunately. I'm so sorry. I know you're like, oh my gosh, I really wanted to find it. Oh, I know, I'm sorry, kids. Okay, so first off, this is going to be the more complicated examples. We're going to be spending probably during these examples at least 4 of them. So we have 4 examples like this because these are the actual bulk of the lesson. This is what actually is the most confusing part right here. And more than likely, students will always get confused with the quadrants. They're not getting confused. When I taught it, when I usually teach it, they don't get confused on the previous slides. They get confused right here when we start introducing quadrants. I want to find cosine of alpha plus beta. I want to find sine of alpha plus beta. And I want to find tangent of alpha plus beta. Okay? I want to find all of these. So I'm going to start out really simple, really nice for you. I'm not going to start out really, really mean. Okay? So what does this mean? Okay? Wants us to find all of these. How do I find all of these? Okay? Well, I look at and see what they're giving me, and they're giving me sine of alpha is 24 all over 25, and they say quadrant 1 is where alpha lies. Now, sine of beta is 4 over 5, and that's lying in quadrant 2. So what's happening here? My very first step, before you do anything, is to develop your first and second quadrant. I'm given quadrant 2, I'm given quadrant 1, so let's go over here and actually develop quadrant 1 and 2. So I'm going to write it out, And then I'm going to actually do my extending lines here. Does this look familiar? Should. You should be very familiar with this. Okay, do my little right angles. So they say alpha lies in quadrant 1, so I'm going to write alpha. Beta lies in quadrant 2, so I'm going to write beta here. So far, so good? Yes? All right. Okay, so now what I'm going to do is I'm going to look at what they're giving me. So let's start with alpha here. So sine is, by definition, opposite. So 24 all over 25, my hypotenuse. So 24 all over 25, okay? Now, we've done this a lot. How do I find the missing side? You should already know this side is 7, okay? If you don't know that, Pythagorean theorem, baby. Like Pythagorean theorem. So you would do 25 squared equals 24 squared, and then plus my missing side, x, okay? And then you would go down through that. I'm not going to waste the time on trying to find that out, okay? I'm not going to spend the time trying to figure that out. You can figure that out yourself, okay? Or I'm just going to tell you, okay? But on the homework, they will not give you that missing side. You do need to figure it out by using Pythagorean theorem. I trust you know how to do that, how to find that missing side. Okay, I'm going to put this in parentheses just to let you know that it is the missing side that we find it using Pythagorean theorem, and you'll see me do that throughout this lesson. So let's go to beta now. Beta is lying in quadrant 2 right here. Opposite all over hypotenuse, so opposite all over hypotenuse. Notice how sine is positive here because all students take calculus, so sine is going to be positive here, okay? So makes sense, it's going to be positive. What is this? You should absolutely know what that is before doing even Pythagorean theorem. It is -3, okay? 3, 4, 5 triangle, and of course I'm putting it as a negative because it's over and then up, so this point right here is technically -3, 4 if I wanted to do the point. That's just from 5.3 from last unit. And I have it in parentheses because I find it using Pythagorean theorem if I wanted to. So those are my missing sides. Now let's go to town. I am going to go over here, and I'm actually going to write out the formulas just in case we forget. So this is going to be cosine of alpha times cosine of beta minus. This is going to be sine of alpha and then times sine of beta. Okay, this is my formula. I'm going to cloud it just so that you know it's not my answer, it's my formula. And now we can actually start solving this. So what is cosine of alpha? Well, cosine of alpha, I'm looking at alpha. Am I going to look at beta? Am I going to look at the quadrant 2? Yes or no? If it says cosine of alpha, am I going to remotely look at beta? No. Okay? No. That doesn't make sense, right? You need to look at alpha. If it's asking for alpha, you look at my triangle that I built for alpha in the first quadrant. And so alpha is corresponding to cosine, so that means it's going to be adjacent all over hypotenuse. So this is 7 all over 25 times. What is cosine of beta? Now, cosine of beta, are you going to look at alpha, the first quadrant? No, you're going to look at the second quadrant where beta lies. So adjacent all over hypotenuse. So my beta, cosine of beta, following my formula, is -3 all over my hypotenuse, which is 5. Okay? Now you can put them in parentheses if you want to. Oftentimes I do. I don't know why I'm not doing it right now. I guess it doesn't really matter. But you don't have to. Sometimes I do. Sine of alpha. Again, look at alpha, where alpha lies. Sine is opposite 24 all over adjacent. Or sorry, that's tangent. Opposite all over hypotenuse. So 24 all over 25. And then sine of beta, look at my beta now, opposite over hypotenuse, which is 4 over 5, which I already have, which is great, right? So I already have that. And I already had sine of alpha, and I can just use those. I can look either up here where I already had them, or I can look on my triangle. So this is 4 over 5. Sine of beta is 4 over 5. Now I can start simplifying. 7 times -3 is -21. 5 times 120. 5 times 5 is 125. Okay, and this is going to be minus 4 times 24 is what, 96, I think. I'm not good with multiplication. I don't want to make any mistakes here. I know you're like, really, Carlson, really? Yeah. Okay, I was right. All right. I'm just double checking. I don't want to make any mistakes. Oops. And this is why I use parentheses. Okay, this is minus. Oh my gosh, I'm going to erase all this. I'm like wasting time here. Okay, so this is going to be 96. And then all over 125. And then if you take 96 plus 121, you do get 117. But make sure you have that negative here. A negative 117 all over 125. Boom. Sweet. Awesome. So that's my answer. Okay, that's my answer. I hope that makes sense. I'm going to go now to sine. Okay, sine of beta. And so when I do sine of beta, I'm going to actually write out my formula. So this is going to be sine of alpha, and then times cosine of beta. And then this is going to be plus cosine of alpha, and then times sine of beta. Okay, so this is my formula. Now let's start going to town on this. Sine of alpha. Now you have a couple options here. You could literally just look at what you did. Like right here, this is sine of alpha. Okay? And we already have it right here. So that's one thing that you could do. Or you could just go back to your triangle and do the exact same thing. If your triangle right here as your first step is solid, then you're good, right? So that is sine of alpha. Now cosine of beta, I already have cosine of beta. It's right here. So cosine beta is adjacent over hypotenuse, so negative 3. I will put this in parentheses, negative 3 all over 5. And then plus, and then cosine of alpha is going to be right here, 7 over 25, or the exact same thing, just 7 adjacent over hypotenuse on my alpha triangle, so 7 all over 25. And then times, and then I'll put this in parentheses, sine of beta is the exact same thing, so 4 all over 5. And that's what's given to me. Or I can use my triangle, it does not matter, okay? So now when I have all this, I start simplifying it out. When I start simplifying this out, this will be negative 72 because 24 times 3 is negative 72. And then this is going to be 125. And then this is going to be plus. This is 28. And then all over 125. And then this equals, when I go to town on these, this is going to be negative 44. And then all over 125. Okay? Sweet. So that is sine of alpha plus beta. Now notice, I don't care what alpha and beta are. That's the whole way through. I don't care what alpha and beta are, which is great. Now, tangent, remember, this is y all over x, sine all over cosine, which is the same thing, and that's what I'm going to use. I'm going to use alpha plus beta. Now, if alpha plus beta of sine, and then I'm going to use cosine, and then alpha plus beta. Okay? This is the formula I'm going to use. Now, I could use the other formula I showed you on the previous slide, right? I could use that formula, but again, I'm not going to. It's actually more work because this is really easy. You ready? What is sine? Now, don't get this mixed up. I know on Math Excel, you will be so tempted to look at your first one that you put on there, cosine. And then you'll put negative 17 all over 25 and then all over negative 44 all over 125. Don't do that. That's cotangent. Okay? What you want to do is do sine. So this is negative 44 all over 125. And then all over, I don't have enough room here. This is all over. And then my cosine, so negative 117 all over 125. So that's what it technically looks like. Okay? Now, when this happens, guys, of course, you should know this by now. Your bottoms go poofy, okay, because they're both 125 when I multiply by the reciprocal. And then what I'm left with is a negative with a negative gives me a positive. So I'm left with 44 all over 117. Okay. Some students may ask me here, like, how do you know if it's negative or positive or positive? The formulas work themselves out that way. Okay, the formulas work themselves out. So this tells me that whatever alpha plus beta is, I'm either in the third quadrant for this angle, okay, whatever angle that is, I don't know, okay, whatever angle it is, I'm either in the third quadrant because tangent is positive here and they're both negative, or yeah, I am in the third quadrant because they're both negative. So I was thinking like I'm either in the first or the third quadrant because it's positive. That's not right. So since these are negative and this is positive, this tells me whatever alpha plus beta is, whatever they add up to be, I'm in the third quadrant here. Okay? And you're like, how does that make any sense? You're in the first and second. No, alpha is in the first quadrant. Beta is in the second quadrant. But when I add them together, I get into the third quadrant. When I take these two angles and add them together, whatever they are, I don't care what they are. I don't know what they are. I don't want to know what they are. But whatever they are, when I add them together, as such, alpha plus beta, I get into the third quadrant. Okay? That's what it's saying. And I know that's true because just look, I have tangent as positive and the rest are negative. Okay? I'm not going to find the other trig functions, okay? Because I don't need to, and nor is it going to ask. But could I? Yeah, I could. I could just flip them. Okay? I hope that makes sense. Okay, that one was, to put it lightly, an easy one. Okay? These next two examples are going to be very difficult. I'm going to say that just straight up. These next two examples are going to be very difficult because there's a lot of radicals. There's a lot of radicals, and it's a lot of math, a lot of algebra. Okay? So pay very close attention because you will have one of these, I'm pretty sure, on the homework quiz, at least one, and you will have at least 3 or 4 on the homework, I think. Okay, so let's erase and let's get into the harder ones. Okay, very difficult ones. So this one right here. I want to find sine of alpha plus beta. I want to find cosine of alpha plus beta and then tangent of alpha plus beta. So I'm going to do each one by itself. I'm going to do sine first, and then I'm going to do cosine, and then I'm going to do tangent. Okay. So first thing I want to do is actually develop my triangles here. So it tells me lies in the second quadrant here. It lies into the first quadrant. So I'm going to do the exact same thing that I did before. Get my quadrants out. So I have my line here, and I have my line here. My beta is in the first quadrant, so I know my alpha is in the second quadrant right there. Awesome. So now tangent, this is the first step. I need to do this first. Tangent of alpha, now notice it's in the second quadrant. Doesn't surprise us why it's negative because only sine is positive there, right? So tangent is opposite over adjacent, so that means opposite, which is 5, all over adjacent, which is 12. Which one gets the negative? Because it is negative, I need to make sure the negative goes with the 12. That's very tricky here. Okay, it's very tricky. You would think you would need to put the negative with the 5, but you should not, okay, because the 5 goes up. Now, what is this right here? Well, this, when I solve it, is going to be 13, so I'm going to put that in parentheses, 13. Pythagorean theorem, okay, Pythagorean theorem. I'm not going to show that for the sake of time. And then right here, I have cosine of beta. Cosine of beta is adjacent all over hypotenuse. So adjacent, which is 5, all over hypotenuse, which is 6. Of course, it's positive. It's in the first quadrant. What is my y value here? When I do Pythagorean theorem, I actually get radical 11. And that is going to be very nasty, okay? It's going to be very nasty for us. So we're going to try to take it one step at a time, though. Let's do sine first, okay? Sine first. I'm not going to show you the formula, okay? I'm not going to show you the formula, but this is A, sine of alpha plus beta. Again, I'm not going to show you the formula. I hope that's okay. All right, look back at your formula when I get these values, okay? When I get these values. I'm going to find first sine of alpha. Okay, sine of alpha. So sine of alpha, I go over here. What's sine of alpha? It's going to be opposite, alpha, opposite 5 all over hypotenuse, which is 13. So that means it's going to be 5 all over 13 times. I'm going to do cosine of beta. So cosine of beta is right here. They already gave us, so 5 all over 6. So that's not bad. So if you're thinking like, okay, Mr. Carlson, like, show us something. All right. So the formula says plus, so I'm going to do a plus. That's just taken from my formula. Again, I'm not going to show you that. Look at your cheat sheet here. And then I'm going to look at sine of beta. So sine of beta is going to be radical 11. Okay, so radical 11 all over 6. And then times my next one and my last one is cosine of alpha. So cosine of alpha is adjacent all over hypotenuse. So I'm going to put parentheses here because it's negative 12 all over hypotenuse, which is 13. Now, I will say this. You know you are doing it wrong when you don't have similar denominators. I'll say that again. You know you're doing it wrong when you don't have similar denominators. Notice how my denominators are similar. And when I multiply these together, I can combine them afterwards. Yes? Yes? So that's how I know I'm doing it correctly. Okay? If this was like, let's just say on this fraction, this was like 50, and this fraction, when I multiply out the denominators, it was like 75. I did it completely wrong. Okay? You know you're doing it correctly so far when they sort of look like this, where it's 6, 13, 13, 6, in that kind of general format. And so when I multiply them together, I can actually add them together. Okay? So when I add these, or multiply them together, 5 times 5 is 25, so I'm going to take that. And then 13 times 6 is 78. Okay? 13 times 6 is 78. Now plus, I have a negative here, so this is going to be a negative 12 times radical 11 all over, and then, of course, 78. You see how this can get sloppy really quick? And then when I add these two together, what I get is 25 minus 12 times radical 11 all over 78. Okay, this is my sine of alpha plus beta. So far I know the alpha plus beta is either in quadrant 2 or quadrant 1. Okay, the alpha plus beta. Beta alone and alpha alone are in these quadrants. But when I add those two angles, whatever they are, I know since sine is positive here, it's more than likely going to be in quadrant 1. Now, I don't know what 12 times radical 11 is. Let me try to actually figure that out. Hold on, give me a second. Okay, so that's 39. So this 39.8. So actually this is negative, okay? Either way, it doesn't matter which quadrant it's in. I just think it's interesting to kind of see which quadrant it's in if I add alpha plus beta. That's all I really care about. But it doesn't matter. The problem doesn't ask for that, so I'm not going to spend any more time on it. Okay, so B, cosine. Let's do cosine. So cosine of alpha plus beta, okay, equals cosine of alpha plus beta. I'm not going to give you the formula again. I'm just going to do cosine of alpha plus beta and give you the answer. So cosine of alpha, that's the first thing it's going to ask us. Cosine of alpha, so I go over here, it's negative 12 all over 13. So I'm going to put this in parentheses, negative 12 all over 13, okay, times. And then it's going to be cosine of beta. So cosine of beta is right here, 5 all over 6. So I'm going to do 5 all over 6. And then there's going to be a minus in my formula. Again, look on your trig sheet, the one I showed you on Google Classroom. I'm not going to spend the time going through it, okay? So just look at it. I'm following this formula. And then that one was cosine of beta. Minus is what the formula says. Now it's going to ask for sine of alpha times sine of beta. So sine of alpha is, right here, 5 over 13. So I'm going to do that, 5 all over 13. Okay? And then times sine of beta, so sine of beta right here, beta, opposite all over hypotenuse, so radical 11 all over 6. Okay? When I equal this, negative 12 times 5 is negative 60. And then this is going to be minus 5, radical 11. And then I'm going to combine them all together here. I'm going to skip this extra step because 13 times 6 is going to be 78, just like before. Okay? Perfect. So this is cosine of alpha plus beta. Okay? Don't care what quadrant it's in. Don't care if it's negative or positive, but that's cosine of alpha plus beta. And you may be thinking, really? That's not that hard. I'm going to erase sine and cosine so that when we get to tangent, I have enough room. Okay? Because it's very, very long. All right? So get these down. I'm going to erase. And I'm going to use for tangent, because I still need to find tangent, I'm going to say sine this all over this. Just imagine what that will look like. This whole monstrosity all over this whole monstrosity. Okay, so let's erase. Make sure you have them down. Okay, now let's go to tangent. So C. Oh man, I erased my my triangle too. That's okay. I don't need it. So C, tangent of alpha plus beta. This formula is sine of alpha plus beta all over cosine of alpha plus beta. Okay, so that's what this is. So now my sine of alpha plus beta was 25 minus 12 radical 11 all over 78. That was sine. And this is going to be divided by cosine, which we found is negative 60 minus 5 radical 11 all over 78. Okay? Okay. What is this? Well, the 78s go poofy, right? They go poofy right here. So now what I'm left with is this equals, I'm left with 25 minus 12 times radical 11 divided by negative 60 minus 5 times radical 11. And yes, you need to rationalize. That's what makes this problem so difficult, okay? You do need to rationalize this, and this is what makes it so hard, okay? So difficult, okay? How do I rationalize this? Because Math Excel will not accept this. And I know I'm mean, neither will I, okay? I may give you like 10% credit, but that's not going to do anything. In fact, I probably won't even give you any credit if you have this. I probably won't. How do I rationalize it? Well, you see how there's a negative here. I need to eliminate my radicals in the bottom, in the denominator. How I do that is multiply it by the radical conjugate, okay? How I do that? Well, when I multiply by the radical conjugate, what I'm going to do here is this. So this is negative 60 plus 5 times radical 11. Okay, negative 60 plus 5 times radical 11. I want to make sure that the radical gets the positive so that when I multiply all this out, my outer and inner terms, when I FOIL this out, will go poofy. My radicals will go poofy, and I'm left with an actual number here. Okay, and I'm going to do the same thing to the top because what I do to the bottom, I do to the top. Okay, so far so good. And now when I start multiplying this out, it's going to be really nasty. Are you ready? I'm going to give you these answers, but I highly encourage you to actually, I'm going to take it slow, but I highly encourage you to actually go on your calculator and multiply them through to double check my math. So 25 times negative 60. Again, I'm foiling here. Okay, I'm foiling, and you're like, oh my gosh. I'm like, yes, oh my gosh. I'm foiling here. 25 times negative 60. 25 times negative 60 is negative 1,500. Okay? All right. 25 times, this is my outer term now for FOIL. First, outer, inner, last, F-O-I-L, FOIL. First, outer, inner, last. This is my outer term. 25 times radical 11. So 25 times 5 is going to be 125, and then I just tag on the radical 11. So that one's not that bad. Now I take my inner terms. So right here, negative 12 times negative 60. Negative 12 times negative 60 is plus 720 because negative times a negative gives me a positive. 12 times 60 is 720. And of course, I tag on my radical 11 here. Okay? You see how this is going to get really intense? Okay, and now negative 12 times my last terms, times 5, is going to be negative 60. But radical 11 times radical 11 is, of course, 121, which is just 11. Okay, so that means it's just times 11. I'm going to put that in parentheses here. So that's all of it foiled out. My numerator all foiled out. Not too bad. Okay, not too terrible. Now, my bottom here, okay, all I care about is, when I FOIL this, all I care about is the first and the last terms. Now, I'm going to show you the outer and the inner terms, but I'm not going to show you in the next couple of slides that, because I know based on what I did here by doing a positive, by doing what we call the radical conjugate, remember complex conjugate or rationalization, we learned this in Algebra 2.1. Remember, I need to do it this way so that it eliminates my radical here. I don't want it in the denominator. I have to do it this way. I have to. There's no other way. Trust me, I know. Okay? If you don't trust me, go for it. All right? Try to multiply it by something, see if it works. All right. So I'm going to show you the whole thing, though. So negative 60 times negative 60. Negative 60 times negative 60 is 3,600. I'm going to show you the whole thing. My outer terms, negative 60 right here, follow my cursor. Negative 60 times 5 times radical 11 is going to be negative 300 times radical 11. Okay? Now I'm going to do my inner terms. Negative 5 times radical 11 times negative 60. Well, negative times the negative gives you a positive. 60 times 5 is 300. See what's happening here? And then, of course, I tag on the the radical 11. So see what's happening here? That's why I did the plus here when I'm rationalizing it. Okay, and then now my last terms, my most important terms, my negative 5 times 5 is going to be negative 25. And then radical 11 times radical 11 is a positive 11. Now notice these will go poofy. And that is exactly what I wanted. So now notice in the denominator, any more radicals? No. Okay, that's what makes it so amazing. So I'm going to continue down here. Equals. Let's start simplifying this. So what can I simplify here? I can simplify a couple things. I can simplify these two things together. Yes? I can simplify those two things together. And then I can also simplify this with this. Okay? So I'm going to do that all in one sweep. I hope you don't hate me for it. Okay? But these two together, when I multiply these two together, or when I add them up together, so 1,500 and then 60 times 11. I'll actually do that real quick. I will show that to you. 60 times 11 gives you 660. And then when I add that to 1,500, I get 2160. So when I add that with 1,500, I get 2160. So this, and since it's a negative, I'm going to keep the negative. So 2160. And then this is really easy in the parentheses here. That's simple. 125 plus 720. 125 plus 720 is just 845. Okay, and of course, since I need the radical there, I tag it on because the radical acts like a variable here. Okay, now all over, now those went poofy. So now I'm taking 3,600 and then adding or subtracting it with that. So I'm going to take it slow though. 3,600 subtract 275. So 25 times 11 is 275 here. Okay? 25 times 11 is 275. Now, when I equal this, my numerator is totally simplified as of right now. Okay, we will simplify it a little bit more, so I'm just going to rewrite it. We're almost there, guys. We're almost there. Okay, and then now 3,600 minus 275 is 3,325. Now notice every single term has a factor of 5 in it. Okay. Now I do not remember if I multiplied it by 5. I can try to figure this out for you. But it's definitely divisible by something. Okay. Definitely not 5. Let's try 25. So, or 15. Let's try divisible by 15. Is that something? No. Oh, it's definitely divisible by 5. So I'm going to divide it by 5 on each one. Okay, ready? So I'm going to take in blue just to see if this actually simplifies it. So divide by 5, divide by 5, divide by 5. So what I get is negative 432 when I divide by 5. Okay, and then this is going to be positive when I divide by 5. It's going to be 169. And then times radical 11 and then this is all over, and then 665. Now, of course, this does not have anything else divisible into it, so that is my final answer. And of course, we need a unicorn on that. Okay, that was tough. Okay, that was tough. I understand that. Again, I took it really slow, actually. In class, I would probably have gone a little bit faster, to be honest with you. Okay, that was tough. I get that. It is a lot of work. Okay, it is a lot of like multiplying and foiling. So review the video, go back through this video. I'm going to show you another one of these. Okay, because I want to show you another long one. All right, just because. All right. So review that video. I'm going to erase, and then we're going to get to another one. Okay. Okay. So first things first, when I want to find sine, cosine, and tangent, when I want to find all these, first thing I need to do is build my triangles. So it says beta lies in the third quadrant. This is the fourth quadrant. So I'm going to build that right here. So third and fourth quadrant. So I'm going to build, and then right here. So beta lies in third. So I'm going to do beta here, and then alpha lies in fourth. So boom, I have it like that. Now, what is cosine? So cosine is 24 all over 25. So all students take calculus. So that's going to be in the fourth quadrant for alpha. So calculus, of course, cosine is going to be positive here. So this is going to be 24 all over 25. Actually, I want to do these in red here. 24 all over 25. And now, if you don't know this already, it's going to be -7. That's going to be my Pythagorean theorem. We already kind of did a similar one like that before. Now, beta here, it's going to be -6 all over 13. So -6 is opposite all over 13, which means I need to find my x value, and this is a whopping negative radical 133. It is gross. Okay, I'm going to put that in parentheses there. So you can find that using Pythagorean theorem, but it is absolutely gross. All right, because 36 plus or minus, when I subtract to find that, 169 minus 36 is going to be 133, and then I need to do the square root. And it's negative because it's a point here. It's in the third quadrant. Okay, so that's a very nasty one. And I'm going to show you how to do this, but I'm going to first do cosine. So now, let's do cosine first. Cosine of alpha, and then plus beta. Okay, I'm going to go through this one a little bit faster. Cosine of alpha is 24 all over 25. I'm going to go through this a lot faster, guys. Okay, and then cosine of beta is going to be negative radical 133 all over 13. I highly encourage you to try to do this yourself, though, without the video, but I am going to do it pretty fast. And then cosine of, sine of alpha right here. Sine of alpha right here is going to be a -7 all over 25. And then, of course, sine of beta is already something that I have, -6 all over 13. Okay. When I simplify all this together, I get a -24 times radical 133 all over 25 times 13 is 325. And then minus, this is going to be plus because these go poofy. So this is going to be minus 42 all over 325. I know I did it right when the denominators are the same. So then when I go to town on this, this is -42 minus 24 radical 133 all over 325. Okay, that's my cosine. Not too terrible, right? Not too terrible. Let's do sine. I'm going to do this a lot faster. So sine of alpha plus beta. My sine of alpha is going to be -7 all over 25. My cosine of beta is going to be negative radical 133 all over 13. And then this is going to be plus, following my formula. Sine of beta is going to be -6 all over 13. That's what I'm given right here, right? And then I'm going to be doing cosine of alpha. So cosine of alpha is 24, also what I'm given. at the top, 24 all over 25. When I simplify all this stuff, what I get is going to be 7 radical 133 because it's negative to a negative, so it becomes a positive. And this, of course, is 325. And then this is going to be minus 144 all over 325. 6 times 24 is 144. When I combine these are negative 144 and then plus 7 radical 133 all over 325. That's the exact value. Awesome. Okay, so I'll give you a second to write those down. Pause the video if you need to. I'm going to do tangent now, and I'm going to put them right on top of each other, and we're going to do the exact same thing, multiply out all the radicals, and it's going to be hell, okay? But that's okay. We're going to do it, all right? So erase. Let's erase. Now let's do tangent. So tangent of alpha plus beta. Now, when I put them on top of each other, sine all over cosine. When I put them on top of each other, I get sine. Be careful. You're going to use the b because a was cosine and b was sine. So you're going to use the b value, and then you're going to do just the numerator. I'm going to skip the step where I cancel out the denominators because we already should know that that's going to happen. So this is going to be 7 and then radical 133. That was sine, and then, of course, over 325, but they go poofy. And then this is going to be cosine. Cosine was negative 42, and then minus 24 radical 133. Very nasty, okay? And yes, I need to rationalize this beast, which means I need to do negative 42, and then plus 24 radical 133. And then what I do to the bottom, I need to do to the top. Okay, so I have that. Okay, now let's actually go to town on this. I'm going to give you the values. I highly encourage you to kind of follow along as best as possible. But when I actually simplify this out, I'm going to FOIL this out as such. So I am going to FOIL it. But I'm just going to start giving you the values, okay? I'm going to FOIL it out as such. So what I have is 6,048 and then minus 3,456 times radical 133. And then my inner terms will be negative 294 and then times radical 133. And then plus the radicals go poofy, so 168 is what I get when I multiply 7 times 24, but times also 133. Okay, that is my numerator. Very nasty indeed. Okay, very nasty. Now let's do my denominator here. My denominator, I'm only going to do the first and the last terms. Okay, my first and last term. So my first term, negative 42 times negative 42, is going to be 1,764. 1,764. And then my last terms, 24 times 24, is going to be a negative. So negative 576 and then times 133. I know my middle terms will go poofy. That's why I did the conjugate here. Okay, so now I don't need to show that. Now let's start simplifying this to be the case. I can simplify this and this together. I can simplify these together, of course. So when I simplify those together, I get a whopping, when I simplify them very carefully, 28,392. Yes, that's a huge number. Minus, and then I have this right here. When I simplify just this and then add it to that because they're the same signs, I get 3,750, and then of course treat the radical like a variable, so radical 133 gets tagged on. And then when I do the bottom here, when I multiply this first, and then I have that, I get negative 74,844. Okay. Now when I get to this end, guys, what I want to do is change the signs here because I don't want the negative on the bottom. So what I want to do is actually change the signs, and that's going to be a negative and that's going to be a positive. Okay, so I do want to change the signs. Okay, I want the negative on top. So now when I simplify, each one is divisible by 2, maybe 4. I don't really remember what I divided it by. You have to guess and check. Definitely not 4, but probably 2. I'm almost guaranteeing you it's divisible by 2. Maybe 6. But I'm going to divide it into it. When I divide that number, what I get is negative 4,732. So that's definitely more than 2 here. It's probably like by 6 almost. I'm almost guaranteeing you it's by 6. And then plus 625 radical 133. So again, I divide each of these numbers, this one right here, this one right here, this one right here, by some number. In fact, I am going to double check, see if it is divided by 6. It is divided by 6. Perfect. Okay. Look at that. I'm awesome. Okay. And then I divide this one by 6. Divide that one by 6. And so this one right here is going to be 12,474. And I don't think you can do anything more with that. I don't think you can. Because I think the next one is 2. You can only multiply it by 2 here. And of course, yeah, you can't divide this or divide it by 2 here, but you can't divide 625 by 2. So that is my final answer. How are you feeling? I hope you're feeling okay. Okay, that's really what I hope you're feeling okay. These are going to be a select few, only a couple on your homework, maybe one on the homework quiz, maybe. I can't even remember. But yeah, if you're honors, you'll definitely see this on the homework quiz for sure. But I know they're hard. I know they're long. So just watch the video again. And then after this, I have 2 more examples. I am going to go through them. I'm going to go through one more like this, but it's going to give you kind of a weird sort of quadrant here. And it's not going to be this long. I promise. I can actually do all the work on one slide. I don't need to erase cosine and sine. And then I have an applications questions, and then we're done. Okay, so let's erase. And let's get started on this one. All right, so this one is very similar indeed than the other one. So I kind of want this to be a checkpoint, which means I want to see if you can do it yourself, but I will help you out for the first thing. So right here, what I have right here is pi. Alpha, it lies between pi and 3 pi all over 2. So what is pi? Well, pi is 180, and 3 pi over 2 is 270. So which quadrant are those the borders? Which quadrant is that the border of? Is 180 and 270 the border of? And that's quadrant 3. So that means I have quadrant 3 here. And then 3 pi over 2 and then 2 pi. Well, that's going to be quadrant 4. Okay, that's the border because this is 270 and this is 360. Okay, so I have quadrant 3 and I have quadrant 4. So I'm going to write that off to the side. So quadrant 3, quadrant 4. Okay, so now what I have is this. And I'm going to erase all this because I don't really need that. Okay. Now, after I give you the quadrants, what I want you to try to do is try to do this yourself. Try to do the whole problem yourself. Seriously, try to do the whole problem yourself. I know alpha, it lies in quadrant 3, so this is alpha and this is beta. Okay, so now that you have this, try to do the whole problem yourself. What I'm actually going to do is I'm going to do a periodic, like this is sine, this is cosine, alpha plus beta, and this is tangent alpha plus beta. Okay, it's not going to be as long as the other two, but it's going to be like the first one that we did like this. Okay, so pause the video, and then when you come back, you'll see the full triangle. Okay, and then we'll pause the video again, and then we'll give you sine, or sorry, cosine, because that's cosine of alpha plus beta first, and then we'll continue that process. All right, so pause the video, see if you can do the triangle yourself. Awesome. So this is the triangle. When I look at tangent, opposite over opposite over adjacent, I need both negative here because they're in the negative quadrant. That is very important, by the way, extremely important. You need both negatives here. And then, of course, Pythagorean theorem is 5 because it's 3, 4, 5 triangle, though. And then this one is adjacent all over hypotenuse, so 2 all over radical 13. And then this is negative 3 because I find my using Pythagorean theorem, I find that to be the case, but I need to make sure I put a negative on it because it's going down. All right. So now what we're going to be doing is we're going to do cosine. So do cosine, try to do cosine yourself. I am going to not show you the formulas. I'm just going to show you the values. I may show you the formulas, but I'm just going to pop it up on the screen in a little bit. So try to do it yourself, though. I really want you to try to do it yourself. Great. So this is cosine. This is what it looks like. I decided to give you the formula there, but this is cosine alpha, cosine beta, sine alpha, sine beta. I did use parentheses because there's a lot of negatives happening here. And then I simplified the first bit right here, simplified the second bit, added them, and then or subtracted them, and now I rationalized. I do need to rationalize, but it's not nearly as awful of rationalization as before. So this is really nice and simple. All I had to do is just do radical 13, and then I get rid of it. And that is my final answer. So now I want you guys to try to do sine. So sine of alpha plus beta. Try to do sine by yourself. Great, so this is sine. Now I didn't rationalize at the end here because we already knew what that kind of looked like. We already knew what it would be when I multiply by radical 13 here. I already know what the denominator is going to be. It's 65, so I didn't want to show that step, but you could technically still rationalize at that point, and you would still get the exact same thing. But this is my final answer. That's my sine alpha right here. Cosine beta, cosine alpha, cosine beta. I just do simplification, and then I get this, okay? So if you got that, awesome job. Go ahead and pause the video one last time. I'm going to show you how to do tangents. Hopefully you can do it yourself. Great. So this is tangent way at the bottom here. So just sine all over cosine, which is great. So I did sine. Don't forget, don't mess up and do the A. I almost did that. Don't do the A. That's cosine right here. Don't do that. Go to the B, what you did for B, and do sine. So it's sine 6 times radical 13 all over 65, and then divided by cosine negative 17 times radical 13 all over 65. I didn't show the 65s going poofy, but that's okay. I'm pretty sure we're confident in that. We know that the 65s, when I put them on top of each other, will go poofy. And so I just did the numerators here. The negatives comes up top. The radical 13s go poofy, and now I have negative 6 all over 17. Way easier than the formula for tangent. I've never used the formula for tangent because it's just a waste of time in my opinion. You can use just sine all over cosine and you get the exact same answer. So if you got that correct, awesome job. Now, that is the hardest part of this whole lesson. We just completed the hardest part of the whole lesson, those 4 examples using the quadrants. So if you thought they were moderately okay, then good job. If you feel like you're kind of struggling a little bit, you need a little bit more time on it, then go back and review some of those, that video, or I have the videos on Google Classroom, not me teaching, but just reference videos, resource videos from Khan Academy, the organic chemistry tutor on the classwork page. I think right above the, right here, right below my master sheet for formulas. Okay, right there. Awesome. Okay, I'm going to erase this. We have one last example, but I'm going to go through it pretty quickly because it is just an application question. I'm given a couple things. A ball attached to a spring is raised 7 feet and then released with initial vertical velocity of 10 feet per second. The distance of the ball from its rest position after t seconds is given by d equals 7 times cosine t plus 10 sine of t. Okay? Okay. So what is this? Well, it's a couple things here. I am given this, but we want to show that this equals this. So it's kind of verifying identities here a little bit. Like, how does this equal that? So I'm going to show you that as well on the third step, whereas theta lies in quadrant 1. So I'm actually going to build quadrant 1 in a little bit, and I'm given this. Okay? But I'm also going to focus on this because this is very familiar. This should look very familiar. Not only is it a difference formula for cosine, but also looks like a graph. So when it asks us for the amplitude, we have it right there. Okay, it's the thing that is multiplied by my cosine graph, by my cosine equation. And so right here, my amplitude is hidden in plain sight, just radical 149. That's it. My period then is just 2 pi all over b, so it's 2 pi all over b. My b is 1 here. It's right above right before the coefficient of my t value, so it's right before my t. So it's just 2 pi all over 1, which of course is just 2 pi. So that's simple and that's done. So this is really my first step. I want to get that taken care of. My second step is really to find what's my first quadrant. Like I need to kind of use this to show this to be the case. So I need to build my first quadrant here. So let's do that. Okay, and so I have theta here. And so that's theta. So my tangent is opposite 10 all over adjacent. So I need to find what that value is. Well, that value, when I actually do the Pythagorean theorem on this, it just so happens to be 149. Okay, so I'll put that in parentheses to know that you have to solve it using Pythagorean theorem. Okay, and I'm just going to let you guys do that yourself, but that's how you solve it, Pythagorean theorem. And so now what I can do is, of course, do my other values. So such as sine. Like what is sine of theta? Sine of theta is going to be 10 all over radical 149. What is cosine of theta? I already have tangent of cosine. I want to find, or tangent of theta. I want to find cosine of theta. So that is going to be 7 all over radical 149. Okay, so now I have this. Now I'm going to go to my third step. My third step is to actually show, based off of verifying identities, how 7 cosine t plus 10 sine of t actually equals this. Okay, or better yet, how the right side equals the left side. So I'm actually going to focus on this and try to I'm going to focus on the right side. I'm going to try to show that the right side equals the left side. Okay, that's what I'm going to do. The right side equaling the left side. So let's actually do that. Okay, so what is this? Well, this is technically, I'm going to put this in parentheses because this is technically a difference formula for cosine, right? That's a difference formula. And then 145, radical 149, oh my gosh. Radical 149 is actually multiplied to everything that will be. So what will this actually look like? It will look like something like this, 149. And then in parentheses, I have cosine of t times cosine of theta. Now, my alpha here is like my t value. So I'm going to actually put that off to the side. My alpha here is like my t value, and my beta here is like my theta value. Okay? And this is going to be plus, and then this is going to be sine of t, because that's my alpha, times sine of beta, which is going to be my theta here. Okay? And then obviously I can distribute that radical 149 through, right? So I can actually distribute that through. So radical 149 times cosine of t times cosine of theta. This is going to be plus, and then radical 149 times sine of t times sine of theta. Now watch this. I'm going to do this in blue here. Now watch. This is going to be radical 149. What is cosine of theta? What is cosine of theta here? Okay, I already know this is cosine of t, so let me actually write that down. What is that's cosine of t. What is cosine of theta? We already know what that is. It's right here, right? That's what I have. So now I'm going to actually plug that in. So 7 all over radical 149. Now what happens? Obviously the radical 149s go poofy, and I'm left with 7 times cosine t. You start to see it, right? So 7 times cosine of t. You're starting to see it? And this is going to be plus. Now what happens here? Let's go back to red. This is radical 149 times sine of t. And now what is sine of theta? Sine of theta is that. So that is 10 all over radical 149. And then, of course, the radical 149s go poofy, so I'm left with 10 times sine. So that means 10 times sine right here. And, of course, that's exactly what I have. So, boom. It actually checks out. Okay? I verified the identity using sum and difference formulas. How awesome is that? So I know that this lesson was extremely long. Okay? I get that fact. And I really don't think that tomorrow's lesson is going to be any shorter. I mean, this is really hard stuff, guys. So I I apologize, but I hope you're learning something. I hope you're really ingraining into it in your brain and getting it, making the connections and everything. Okay. What did we learn? We learned how to use the formula for cosine of the difference of two angles, the sum and difference formulas of force, cosines and sines, and then for tangents as well, sort of. And then we also used the applications. I didn't put that on there, but we also used it using verifying identities and used it in application settings. So tomorrow, homework quiz, 2 extra credit points on the homework quiz for 100% on homework. Please, please, please be doing your math. Please be doing your Math Excel homework as much as possible. But this is C Squared Mathematics. Thank you so much for tagging along and just basically keeping up with me as much as possible, for waiting out until the very end. So until next time, guys, I'll catch you later.